Hello, welcome to this video of supply chain management. Today we're going to discuss the bullwhip effect. The bullwhip effect is one of the most important concepts in supply chain management. It was discovered back in 1960 by J. Forrester, and later on it was perceived in practice in the distribution of consumer products. And we're going to discuss the details of how it's created, why it's important for companies, and how to solve the issues associated with the bullwhip effect. So please stay with me during this video. This software is Bensim. Bensim is a software that allows you to make simulation in a continuous way. The way that the simulation works is that it is describing the passage of time every so often, and you can control how frequent the status of the system changes. So you can decide it to be every day, every quarter of a day, every week, every month, etc. So the way that this system works is that it represents flows, information flows, product or material flow, and stocks. Stocks is where the material is concentrated. In this particular case, the stock is concentrated in each one of the blocks that you can see there with titles: manufacturing inventory, wholesale inventory, and retail inventory. I am depicting right now the simplest of the cases, and as you can see, the lines in the arrows pointing in blue from right to left represent information going upstream in the supply chain, whereas the material is flowing from left to right, from the suppliers to the raw materials to the manufacturer, from the manufacturer to the wholesaler, from the wholesaler to the retailer, who finally sells this product to the consumer. As you can see, I'm going to zoom in so you can have it more clear. As you can see, the flow of the information that goes from the demand to the amount to be sold to the or distributed to the retailer, it is automatically considered. If I go to the formula without getting too technical here, if I show you the formula that I have for that flow, here is the formula. Just says it's equal to the demand. That means that as soon as the demand happens, we're going to know exactly what is the demand, and we're going to just replace that demand from the inventory in the retailer. The demand right now is set up to be 50 right now, and then after 400 units of time, we're going to have an increment of 50 units. That's what this function means. So it's like a little step in which you are at the level of 50 at the beginning of the simulation, and after 400 units of time, this could be 400 days, and I'm thinking it as if it was days, we're going to have an increment in the demand of another 50 units, staying stable for the remaining of the simulation at a total of 100 units. So the information flows back to the wholesaler as well, and the information that the wholesaler receives is just to send or just to replenish the inventory that the wholesaler is sending to the retailer, by exactly the same amount. So there is no delay of the information, and exactly the same information that is happening at the end of the supply chain in the downstream in the demand with the customer is exactly what is happening upstream in the shipments from the manufacturer to the wholesaler. Similarly, the information that we share from the wholesaler to the raw material supplier, it is going to be exactly the same. We can see the formula as the wholesaler replenishment flow. So the product is moving along these lines. The initial inventory is 200, and the formula is just whatever I had originally, the 200 plus the retail replenishment minus the demand, because it's a flow and the product is not to be considered to be lost. Simply the amount of product in the inventory, it's moved or stored at that particular location. And the same happens with the wholesale, but the initial inventory is 1,000, and for the manufacturer is exactly the same type of formula, with the raw material contributed to the inventory, the wholesaler replenishment being an outflow, therefore reducing the amount of inventory at the manufacturer. And the initial inventory is 5,000. Very good. So with these conditions, we can run our simulation. Currently, our model states we're going to run it for 1,000 units of time. That is equivalent to 1,000 days. Remember that the step that we have in the demand is at 400. And if we run the simulation right now for this model, it runs pretty fast. We can compute or observe the behavior of different factors. For instance, let's say the inventory and the demand together. So the inventory and the demand, I'm going to show it like this. And you can see the inventory. You have two lines. One is blue and the other is red. For the scale, you have two scales. The lower value of the scale is 0. And you have two scales. One that it's 400 to, I'm sorry, from 0 to 40, from 40 to 70, from 70 to 100. Actually, no, that should not be to scale. It's just 40. And then this one starts around, or this level is around 100, 150, and 200. And the line at the top is the demand, the line in blue, as you see here in the legend at the bottom of the image. That means that the scale at the top here, the 40, the 70, and the 100, corresponds to the current demand. And the demand is a flow. It's a consumption per unit of time. And you can see it started at 50, just above 40. It started at 50 for 400 units of time. And then suddenly, from the next moment, it's going to start to be consumed at a rate of 100 units until the ending of 1,000 units of time. What happened with the inventory at the retailer? It remained constant. Why? Well, it started with 100, and it remained at 100 because everything that was consumed was immediately communicated to the retailer, to the wholesale. To the wholesaler, from the retailer to the wholesaler, and the wholesaler replaced the inventory at the retailer, and therefore everything looks very smooth. No need for any concerns, and this is a very good outcome because the information is flowing fast. If we make the analysis for the replenishment and the retailer and its inventory, we can see as well the replenishment is just increasing from 100 to 200, and the inventory at the retailer again remains at 100. Now, what happens with the inventory and the replenishment to the wholesaler? We're going to have exactly the same behavior, but we started at 900 with the inventory. No, I'm sorry. We started at 50, and then for the let's see, there you go. The replenishment, that's the flow, started at 50, and then we incremented it to 100, which is exactly what we needed. And the inventory at the wholesaler remains at its target of 1,000 units, and there is no problem. And finally, we're going to show the raw materials and the manufacturer. And again, you have exactly the same behavior. You have the raw materials in red, the flow, the material shipments in red, and the manufacturer inventory in blue. And the manufacturer inventory remains at 5,000 all the time, which was the objective, and the shipment just switches from 50 to 100 at t equals 400. So this is a very good behavior. We don't have any bullwhip effect in this case. The benefit is, as you saw in the lines, the communication flows immediately to the other position. As you saw, when the information flows speedily, there is no problem with the information, with the levels of inventory, and the supply chain management works very smoothly. But that's not always the case. In reality, we have other constraints, and in the following video, we will discuss a simulation in which we have precisely that situation. So go to the next video, please.